Okay, hi again, and welcome to the MediaFutures seminar. We have a great pleasure to have Denis Kotkov. He's a postdoctoral researcher at University of Helsinki and kindly accepted to give us this seminar. And as you might have seen already in the announcement, the topic of the seminar is going to be, the title is going to be Overview of Serendipity in Recommender System. Thank you very much. The stage is yours.
Yes, hello everybody. My name is Denis Kotkov, and today I would like to present to you an overview of serendipity in recommender systems. First, I'm going to talk about definitions, then about experiments, then I will come back to definitions and talk about experiments again. Then I will talk about algorithms, and I will conclude by highlighting a possible future direction of this topic. Recommender systems are software tools that suggest items such as movies or articles to users. Let's say there is a user. His name is Johnny. Johnny likes the Lord of the Rings movie. But if we keep recommending to him only Lord of the Rings movies, probably these recommendations are going to be relevant and accurate. But Johnny will probably find our system boring. That is why recommender systems are optimized not only for accuracy, but also for novelty, diversity, and serendipity. We conducted literature review and found that serendipity has multiple definitions in recommender systems, but most authors describe serendipity with these three components: relevance, novelty, and unexpectedness. Where relevance indicates that the user likes an item, novelty has two variations. One is that the user is unfamiliar with the item, and another one, maybe the user is familiar with the item, but just doesn't think about this item when we make this recommendation. Unexpectedness has four variations. I'm not going to go through all of them, but just going to give example of one of them. For example, let's say that I only watch comedies, and then I'm suddenly recommended a horror movie. Then I might find this movie unexpected, because it is very different from movies that I usually watch. And not all the authors require all three components to be present in serendipity. Some authors require an item to only be, for example, relevant and unexpected to be considered serendipitous, while some other authors only require an item to be unexpected to be considered serendipitous. And out of curiosity, I decided to calculate the number of ways how we can define serendipity in recommender systems, given these building blocks and their variations. And this number turned out to be 28. And of course, not all these definitions have been used in the literature, and also some of these definitions are used more often than others. However, this gives an idea of how many degrees of freedom a researcher has when they pick a definition of serendipity. Here is an example how we can label an item serendipitous. Let's say that Johnny logs into our movie recommender system to find another Lord of the Rings movie, but instead comes across the Particle Fever movie, which is a documentary about the Large Hadron Collider. Let's say that Johnny has never heard about this movie and doesn't usually watch this kind of movies, but decides to watch this one and likes it. Then we label it serendipitous for Johnny because it meets all requirements for an item, all three requirements for an item to be serendipitous. And why would we recommend serendipitous items? According to our literature review, most authors indicate that serendipity broadens user preferences. And to give an example, to measure preference broadening, we use this statement. Watching this movie broadened my preferences. Now I am interested in a wider selection of movies. And they also indicate that serendipity increases user satisfaction. For example, I am glad I watched this movie. However, before 2018, there have been no experiments that would support these claims. That is why we decided to conduct one. These were our research questions. What are the effects of variations of serendipity and its components on preference broadening and user satisfaction? And what are the effective features for detecting serendipitous items? We didn't look at 28 definitions of serendipity. but we picked the most common definition of serendipity, which is that the item needs to be relevant, novel, and unexpected. And we looked at each variation of each component. Since there are 4 variations of unexpectedness, 2 variations of novelty, and 1 variation of relevance, this resulted in 8 variations of serendipity. We conducted our experiment in MovieLens, which is a movie recommender system where users rate movies on the scale from ½ star to 5 stars after they watched the movies. We invited users of the system to our survey, and for each user, we picked 5 movies that were recently watched because we wanted to make sure that users still remember their experience with these movies. Rated with at least 3.5 stars, we picked only relevant movies, and also those that are unpopular, because serendipitous items tend to be unpopular. This is a survey page that the user needed to fill in. The user needed to reply to statements regarding novelty, unexpectedness, and, for example, preference broadening. Around 500 users joined our survey and gave their feedback on around 2,000 movies. Out of these around 2,000 movies, 63 to 181 were serendipitous. And depending on the definition of serendipity, this number varied from 63 to 181. We analyzed our data and found that all variations of serendipity components, of relevance, of novelty and unexpectedness have positive association with preference broadening. We also found 1 variation of unexpectedness, which has a negative association with user satisfaction. And that was the variation of unexpectedness when the user doesn't think that they would enjoy the movie before watching this movie. We also found that almost all variations of serendipity are positively associated with preference broadening. And we analyzed this strength of associations and found that the strength is different depending on different variations of serendipity, implying that it is important to distinguish between different types of serendipity because they might affect users differently. We also detected effective serendipity predictors. They were the rating that MovieLens predicts that the user is going to give to the movie, popularity of the movie, and similarity of the movie to the movies that the user watched in the past. But we haven't found that serendipity is associated with user satisfaction. But there was another study where the authors did find this link. And this is the study by Chen et al. They conducted a survey in mobile Taobao with more than 3,000 users. The authors used the structural equation modeling to analyze their results and found that relevance, novelty, unexpectedness, and timeliness, which indicates that the recommendation is provided on time to the user, these concepts are positively associated with serendipity. The authors had a separate statement about serendipity in the survey. And the authors also found that serendipity is positively associated with purchase intention and also with user satisfaction. The authors also found that user curiosity has an effect on the association between novelty and serendipity. There was also another study where the authors found that serendipity is domain dependent. The authors analyzed the data set that we collected in our MovieLens experiment and the data set collected in the Taobao experiment. And they found that some observations are the same in both domains. For example, serendipitous items tend to be unpopular, both in the movie domain and the e-commerce domain. But there are also different observations in different domains. For example, let's say, the more similar the movie is to movies that I watched in the past, the less likely it is that I will find this movie serendipitous. But the opposite is true for the e-commerce domain. The more similar the product is to the products that I bought in the past, the more likely it is that I will find it serendipitous. And now I would like to come back to the beginning of the talk when I discussed definitions. the way serendipity has been defined in the recommender systems does not correspond to the original definition of serendipity. Originally, the term serendipity was coined in 1754 by Horace Walpole when he referred to the old Persian fairy tale, the three princes of Serendip. He wrote that the princes were always making discoveries by accidents and sagacity of things which they were not in quest of. Later, the sociologist Robert K. Merton collected mentions of the term serendipity from magazines and journals to investigate its use context. And in 2018, Ohid Jakub used archives of Robert K. Merton and proposed the topology of serendipity, which included 4 definitions of serendipity. To give example of 2 of them, let's say I put on a jacket and I find 50 euros in my pocket. If I had been looking everywhere in my apartment for this 50 euros, and the last place where I could think I have this 50 euros is in my pocket, this is one kind of serendipity. If I hadn't even been thinking about 50 euros and I find them in my pocket, this is another kind of serendipity. And if I had known that I have 50 euros in my pocket, this is not serendipity. And we applied these 4 definitions of serendipity to recommender systems and proposed generalized serendipity. An item is generalized serendipitous if it helps the user to achieve at least one goal different from those they set out to achieve with the recommender system. Let's say that Johnny logs into our movie recommender system to find another Lord of the Rings movie. But again, comes across the Particle Fever movie, watches it, and likes it. We label this movie generalized serendipitous for Johnny because it helped him to achieve a goal that is different from goals that he planned to achieve with this recommender system. Or in other words, Particle Fever is the movie that Johnny didn't plan to find, but found and liked it. Now I'm going to refer to the definition used in recommender systems as Rex's serendipity. Rex's serendipity covers some cases that are also covered by generalized serendipity. For example, Johnny coming across and liking the movie Particle Fever. But there are also cases that are covered by generalized serendipity, but are not covered by Rex's serendipity. For example, let's say that Johnny wants to explore new kinds of movies, but comes across the Lord of the Rings movie. He watched it and he likes it. In this case, this movie is no longer going to be Rex's serendipitous because this movie is not different from what Johnny usually likes. But this movie is going to be generalized serendipitous because it helped Johnny to achieve a goal which is different from the goal that he wanted to achieve with this recommender system. The key difference between these definitions is that generalized serendipity is based on user goals or based on what users want to find, while Rex's serendipity is based on these components: relevance, novelty, and unexpectedness. It doesn't take into account user goals. And we conducted a field experiment to investigate these definitions. We also included user serendipity. This definition depends on a particular user. Different users might define this term differently. And we decided that it is important to take this definition into account because it is important to understand what users mean when they request serendipity in the system. We included these 3 definitions in our experiment: generalized serendipity, which is based on user goals; user serendipity, which depends on a particular user; and Rex's serendipity, which depends on serendipity components. And here again, we didn't look at 28 variations of serendipity. We picked the most common variation of each component of relevance, novelty, and unexpectedness. And we looked at all combinations of these components. For example, we looked at unexpectedness alone, we looked at the combination of relevance and novelty, and we also looked at the combination of all 3 components. It is important to note that relevance alone is not serendipity because it is already reserved for accuracy. These were our research questions. To what extent do various definitions of Rex's serendipity capture items considered serendipitous under generalized and user serendipity? And what aspects of user behavior are associated with different serendipity types? We run our field experiment in Soli, which is an article recommender system designed for Android and iOS. And when the user logs into the application, they need to indicate their interests. And then when the user uses the application, every day we ask the user why they're using this application. The user can select their goals from the predefined list of goals, or they can add their custom goal. Then the user goes to the hub page where they can see 15 recommendations, article recommendations. 12 of these articles are within user interest, and 3 articles outside user interests. And all the articles from these categories are picked randomly from the database. After reading an article, the user is asked to reply to the survey, where they need to indicate whether this article was relevant, novel, and unexpected to them, and also whether it was serendipitous, based on how the user understands this term. We also ask the user to indicate goals that this article helped them to achieve. And if this article helped the user to achieve at least one goal different from the goals that this user set to achieve with this recommender system, then we label this article generalized serendipitous for this user. The user can also interact with these articles. They can hit the like button or bookmark an article. We ran our field experiment for 16 weeks, and more than 600 participants joined our study. Around 400 of them completed at least one goal and article surveys, and we focus on this subset of our dataset. We also recorded the time spent in the system and reading progress of articles and interactions with these articles. These are distributions of goals that users plan to achieve with Soli and achieve with articles. And we noticed this peculiar observation that improve myself was the most desired, one of the most desired, but the least achieved goals. The first key finding of our study was that recommendations that should be considered serendipitous have been overlooked due to the narrow definition of serendipity used in recommender systems. And we can already see that from raw numbers. We received user feedback on around 2,000 articles, and around 1,000 of them were generalized serendipitous, around 700 of them were Rexy serendipitous, and around 800 of them were user serendipitous. To analyze this data, we used classification metrics, precision, recall, and accuracy. And we found that in the best case scenario, serendipity types only captured 2/3 of generalized serendipity. Our second key finding was that user understanding of serendipity differs from generalized and Rexy serendipity. Again, with precision, recall, and accuracy, we found that serendipity types capture, in the best case scenario, they capture just over half of user serendipity. And our third key finding was that different types of serendipity are associated with different patterns of user behavior. To investigate associations between serendipity types and user behavior, we used mixed effect logistic regression models. And we found that most serendipity types are associated with interactions and reading progress. Generalized serendipity was only associated with reading progress. The combination of relevance and novelty was associated with all measured behaviors. And for unexpectedness alone, we haven't found an association with any measured behaviors. The key takeaways of our study were that Rex's definition misses items serendipitous under other serendipity definitions, implying that algorithms optimized for one type of serendipity are unlikely to satisfy another. And another takeaway was that user understanding of serendipity differs from generalized and Rexy serendipity, implying that optimizing for serendipity might not meet user expectations of the system. Now I would like to talk about algorithms. And there are different ways how we can improve serendipity of a recommendation algorithm. One way is to change the input data of the algorithm. Another way is to change the model of the algorithm. For example, we might change the objective function of a matrix factorization algorithm. And finally, we can rerank the results of an accuracy-oriented algorithm. But today, I would like to talk about one strategy that we used to increase serendipity of a recommendation algorithm. And that was transfer learning, which we applied to neural collaborative filtering. Neural collaborative filtering consists of 3 parts: generalized matrix factorization, which is very similar to matrix factorization, multi-layer perceptron, and the neural matrix factorization layer. Usually, we first train generalized matrix factorization and retrieve user and item latent representations. Then we train multi-layer perceptron and retrieve the output of the last hidden layer. And then we concatenate these vectors, concatenate latent representations of items and users, and with the output of the last hidden layer. And this vector becomes an input, the input for neural matrix factorization layer. And then we train this layer. We applied this algorithm to our serendipity dataset that we collected in the movie lens experiment. In this dataset, some relevant scores are associated with serendipity scores. So we know that the user liked a movie, for example, and we also know if the user, for some movies, we know that the user found it serendipitous or didn't find it serendipitous. And we split our dataset into 3 parts: training, validation, and test. Since serendipity scores are very rare because it is very difficult to collect them, we need to ask users many questions to label a movie serendipitous or not. That is why there were very few of them, and our training data set was missing serendipity scores. But our goal was to predict the serendipity scores in our test part of the data set. So we applied Colon strategy. We trained this whole structure on serendipity scores of the validation data set, and we evaluated this whole structure on the serendipity scores of the test part of the data set. And then we improved serendipity by applying transfer learning. We trained generalized matrix factorization and multi-layer perceptron on relevant scores of our training data set. And then we tuned this whole structure by training a neural matrix factorization layer on serendipity scores of our validation data set. And then we evaluated it on serendipity scores of the test part of the data set. And in this way, we improve serendipity of this algorithm. Now, if you would like to evaluate your own serendipity-oriented algorithm, here is the list of data sets that contain serendipity labels. There is a data set collected in movie lens experiment, the data set collected in the Taobao experiment, and also SerenLens, the data set that contains serendipity labels for movies and books. To label an item serendipitous, the authors used reviews that users wrote when they consumed those items. For example, if the user wrote, "By chance, I downloaded this book into my Kindle," and then the authors label this book serendipitous to this user. And to annotate this data set, they hired Amazon Mechanical Turk workers. And finally, I would like to highlight one possible future direction of the topic. Most efforts on improving serendipity of recommender systems have been focused on improving recommendation algorithms. But recommendation algorithms are only part of recommender systems. And there are also other parts of recommender systems that affect user experience, for example, user interfaces. This has also been highlighted by the recent paper on serendipity in recommender systems by Smets et al. The authors wrote, the dominant focus on algorithmic improvements in recommender systems has overlooked the importance of user interface design choices. And I believe that user interfaces can improve serendipity of a recommender system by highlighting items that are potentially serendipitous to users. And one of the ways to do that is to generate explanations. For example, let's say that we know that the user has watched the movie Groundhog Day and we would like to recommend them the movie Primer. We might generate the following explanation. This movie has more sci-fi but less comedy than Groundhog Day. Both movies have a lot of time travel. To generate this kind of explanation, we might want to use the tag genome dataset. This dataset has been introduced in 2012, and also we worked on this dataset for more than a year at the University of Helsinki and published a number of papers on this topic. The key feature of this dataset is that it contains relevance scores that indicate the degree with which a tag, such as time travel, applies to a movie, such as Groundhog Day. For example, we can tell that the tag time travel applies to the movie Groundhog Day with a score of 0.7 and to Titanic with a score of 4.2 on the scale from 0 to 1. And that allows us to compare movies between each other and generate explanations. What we can also do is that we can combine two tag genome datasets from different domains. And this will allow us to compare items from different domains. For example, we can tell that the book Hamlet has more drama than the movie Groundhog Day. And this allows us to generate cross-domain explanations. For example, if we know that the user has read the Harry Potter book and we would like to recommend to them the movie Jumanji, we can generate the following explanation. The movie Jumanji has more lions and jungle, but less England and mystery than the book Harry Potter and the Chamber of Secrets. Both have a lot of fantasy, action, and adventure. And by the way, this is an actual example I generated with these two data sets. And we already partially have investigated these cross-domain explanations. Not exactly these ones, but very similar ones in our recent CGIAR paper, which we'll present this summer. In that paper, we evaluated similar explanations and found that they affect user perceptions of recommendations. That is why I hypothesized that these explanations can also affect serendipity of a system. With this, I would like to end, and thank you for your attention.
Thank you very much for the great talk. Now we have time for questions. Here, yeah, please.
Yeah, there are also 10 people online, which is fantastic. And I also see there are some messages in the chat. Is it possible to show this on the screen? But if not, there's no problem. Yeah, so Denis, thank you very much for the nice talk. I have a lot of questions, but maybe start off with the most simple one. Yeah. So you say in one of your slides that you actually label items to be serendipitous. Yeah. So I was wondering, is it even possible? Because you know, the serendipity, as I see it, you also said like there are many definitions to that. Yeah, is context dependent. Yeah, so in a sense, and then I was wondering how can we like label items? So, for example, for to be serendipitous, is that what I'm asking for? Is that like you mean that the item for the user is serendipitous, or is it like in general, like this apple or banana is like in general in the whole cup?
Yes, it depends on the user. One user might find, for example, the movie Particle Fever serendipitous, while the other user might not find this movie serendipitous.
Okay. Good. So that answers the question.
Yes, it's just like with relevance also. Yeah, one user might like Particle Fever movie, another one might not like. Yes.
Or maybe if there's a question in the chat, I can also.
No.
Okay. And then my question would be a follow-up question with regard to Christoph's question. In one slide, you showed the survey. that you asked users on their understanding of serendipity and whether or not they thought it was actually positive and surprising. Is it possible to go?
Yeah, which one? Is it articles or movies?
Survey where you ask the user after either they read an article or watched a movie.
This was in the article.
That relates to Christoph's question. I was just wondering, in my understanding, serendipity is a demanding concept, right? So these types of concepts are not easy to understand for those who are not familiar with them. Then there are several of these concepts, and innovation would be another concept that is not immediately easy to understand. And I just wonder with regard to the research, wouldn't it be easier to ask the user about the core characteristics of serendipity and then try to figure out whether it matches with your core definitions of serendipity? Otherwise, it could be easily misleading for the user to say whether or not that is actually serendipity. It's just a curiosity, it's not a big critique. Just wonder how we can figure that out.
Yeah, I agree. We could ask that. But there is also this work by Robert K. Merton, this sociologist. He collected mentions. So that's, I think, is similar to what, if we ask users what are the characteristics of serendipity, then I think that we can also find it in the work of Robert K. Merton, because he spent decades collecting these mentions in journals and newspapers of this term. And probably there are also, it contains probably many characteristics. And also later this Ohid Jakub, he used these archives to come up with, to generalize them based on these characteristics. This is what I understood there. So I think that it has also maybe partially has been done there. Yeah.
Yeah, I have another question. So from an economical point of view, right? So we have a lot of partners in MediaFutures who are obviously interested in being responsible recommendations, but on the other hand, also earning money from it, right? So because this is basically the business. So I was wondering, what do you think? What do you feel yourself after doing this serendipity research for so long time? How important is it really compared to user preferences? I also don't know that serendipity also includes preferences. I didn't know that before the talk so much. I always was interpreting it as something surprising. I was always measuring like guessing of the diversity in a sense. Yeah, like that was my mistake I had. And I felt like it's important to show the user something new. Also, when it comes to those similarity estimates, you know, our work with DeepMind, where we try to develop new types of functions that measure how items are similar to each other. And actually, the first thing you showed with the movie, and then you know all the Lord of the Rings. Yeah, this is exactly what I do in my research. Yeah, just to make it as most as similar as possible to the user. Yeah. But obviously it's not a good thing always because people get bored, right? And I was wondering if you look into those things like similarity, for example, versus serendipity, yeah, versus diversity, versus popularity. Do you think that like how important is serendipity for such platforms? Should they invest more in it? Is it like concept they should keep on the side? What would be your recommendations, suggestions, and so on?
Yeah, I would look at the key performance indicators of a company, and I would look at their goals, what they want to achieve. I think usually what they look at is retention, right? That the user comes back to the system and uses it again by subscription. And many systems are based on subscription. And then I would look at yeah, I would look at how it affects long-term use of this system, whether users come back. Yeah, and also on user feedback. Maybe they do say that it is boring. The recommendations are boring. Then
do you have like some research or some papers found that look at the long-term retention rate in the context of serendipity? Is there something that shows that if I do stuff more serendipitous, that retention rates are high, or people stay long on the platform, do not unsubscribe, stuff like that. Is there something in this context?
It is partially what we looked at with this time spent in the system. Here is one definition: relevance and novelty. It's positively associated with how much time the user spent. So the more items they find, the more serendipitous items they find, the more time they spend in the system. Yeah, and that was field experiment. So users were using the application kind of in the natural environment. It was not a survey where we put them in the lab or something like this.
I found, that's interesting, is that they were then more interested in the items to read them, like in terms of news articles, because they were so interesting, or was it they were surprised and oh, what the heck is this, and then they were just looking over it because they were surprised to receive that recommendations, because I also had some clients in the past, just to give you an example. I was called into meetings, people showing me recommendations, and then immediately thought, this is what I'm not expecting for a recommender system to show me, that I don't want to see, but then the person spent a lot of time on that item and trying to understand why it's recommended. So you have some sort of explanation why people then spend more time?
Yes, they in our experiment, for example, they seem to be interested in these items because this is a reading progress, and we tracked it based on how much the user scrolled the article based on the scrolling, so almost all the variations of serendipity are positively associated with reading progress. So it might all right. This is of course association. This is not causal relationship. But there is a hint that this might be exactly the case, that that users actually find these items more interesting because they read articles. The reading progress is higher for these serendipitous items than for others.
Thank you.
Online audience. Then maybe I have last question. In this center, you're working on the responsible technology, and in particular, you're working on responsible recommendation and personalization. Do you think Serendipity has any link to responsibility in technology and particular recommendation from your point of view?
I don't know the direct links, but maybe I could think that serendipitous items tend to be unpopular, and when we want to find popularity bias, we can do this with serendipitous items. And yeah, or also fighting filter bubbles. Yeah, this is how we can make it more responsible. Because as in our movie lens experiment, we found that serendipity is associated with preference broadening, and that's exactly when we broaden user preferences, that means we fight filter bubbles. Yeah. So this is how it's linked.
Okay, so it seems that we can conclude the seminar. Thank you very much, all the audience who attended in person and also online. Thanks a lot, Denis, for the great presentation. Let's give another round of applause. And I wish a great weekend for all of you, and see you in the next seminar.
Yeah.
Yeah, thank you.